My name is Tyler Turner, and this is my Phase 3 project for the Lottery of the Lotteries for CS 2316. So the purpose of my project was to find trends that dictate the likelihood of winning a lottery jackpot. So typically when we think of the lottery, we see it as completely random, and it's pretty much the golden standard for being as random as possible. I mean, everyone thinks that there's a very small chance of getting the lottery. However, as we're going to see with the data comparisons, there are actually several different trends that may or may not increase the likelihood substantially or decrease the likelihood depending on different trends. So a few questions I originally asked myself were, why do some regions have substantially more winners than others, at least in the United States? Why do different populations, such as race or gender or age, have an impact on the likelihood of winning? Others questions consisted of, are there different tricks that some can do to increase their likelihood? And another is, what's the best likelihood for them to win based on what kind of tickets they're buying? So I had to find three sources to manipulate to find data. And the first one, this is the downloaded dataset, and I retrieved this data from a file, and essentially it had over 100 rows of different tax information. Now, my goal with this downloaded dataset was to find information on the tax rate of the elderly in each counties. Now, there were a few original inconsistencies with this data. For one, there were a few extra states that actually don't have the Powerball, which is the lottery type that I'm examining in this project. And there were a few other errors. There were many duplicates that I had to end up removing, and this is the code that I ultimately used in order to surf through this. The next dataset was my first web requirement, and this was a table consisting of the amount of winners in each state, the tax rate in each state, as well as whether they were an anonymous winners lottery sanctuary or not. So in order to get this table, I initially used Beautiful Soup as well as regular expressions to find different trends, add them into my own new table. One big inconsistency was that there was not a clear differentiation between when there was no tax rate and whether there was a very small tax rate. For instance, several times null was listed instead of zero, so I had to fix that inconsistency, and this is the code for how I did that. Finally, my third dataset was the second web requirement, and this was used from the lottery website for New York, on a government website that was used to archive all of the past lotteries that they have had within the past 20 years. I initially used regex to access this API and ultimately compile all of the data. There were actually much more inconsistencies in this dataset than there were in the last two. That was because, for many instances, because the lottery in New York for different years would use different numbers. For instance, for one year, the numbers 1 through 25 would be used, and the next 1 through 35 would be used for the Powerball. In this case, many of these numbers were listed as, for instance, 02 instead of 2, or 3 instead of 03. And so these inconsistencies had to be fixed and all replaced. Null values had to be gotten rid of, and a lot of unnecessary data was also gotten rid of. And this is my function data for that. Now, there were 5 ultimate insights that I had for my data. So the first insight was the likelihood of lottery numbers, and that was simply to test whether or not you can actually choose, say, lucky numbers in order to actually win the lottery, and whether this can be an advantage for people if they do want to win the lottery. And what I ultimately found is that the data reveals a downward trend, with smaller numbers being favored. So, for instance, the number 70 has much less likelihood of being on the jackpot ticket as opposed to the number 2, for instance. And this suggests that there are definitely strategies that can be developed to have higher winning chances. My second insight was the likelihood of multipliers. Now, when a multiplier is played, that's when a player pays more money to essentially buy multiple of the same ticket so that they will have a higher likelihood of getting money if there's a tie and they actually do win. And the data in this case showed that the more that a person actually got more multipliers, the less likely chance they actually had of winning, which was actually a surprising insight. third insight was the likelihood of the Powerball. And the Powerball is the additional number, typically 1 through 35 or 1 through 15, depending on the type. And this Powerball specifically is 35. And in this case, it was analyzed through my data to show that with a Powerball, there's no specific trend. But at the end of the day, the Powerball actually is much less significant, than the actual lottery numbers because, again, it is just one number. There was no specific trend found with this, and specifically, it showed that the higher the Powerball number is, just like with the original insight, is less likely to actually be chosen. The fourth insight was pretty interesting, and that was the influence of populations, and that was through my CSV data. And I ultimately showed through my code that elderly populations were shown to have a correlation with this data. They did have a correlation in the sense of different states, in some instances, with a large lottery population combined with a large elder population, they were actually shown to have higher chances, but this was actually contradicted in multiple other states, and there was no real clear difference, so that was a bit of an issue. The fifth insight was the influence of state tax rates, and this actually showed that for the most part, when there is a very low tax rate in a state for actually buying the lottery ticket, there are extreme cases shown, which is pretty interesting. So, for instance, if a state actually has a very low tax rate, say 1%, it's much less likely that they'll have a lot of lottery winners or no lottery winners, but there's very unlikely a chance for there to be a moderate number. I had to compile 3 data visualizations to show exactly how this data looks, not just with Python code or with mathematical calculations, but actually to the eye. And this was the first data visualization. And this showed the winners compared to the amount of rankings for tax rate percentages. And this was going off of Insight 5. And you can actually see that it's very mirrored. If you look at both ends of this graph, you can see that the more amount of winners or the less amount of winners, specifically those two ends, not really in the middle, but in the two ends, you can see the tax rate percentage has a much higher effect and it's essentially mirrored. So what this shows is that if there is a very low tax rate percentage, there are much likely to be more extreme values, whether that be very high or very low. This is the second data visualization, and this was a scatter plot, and it showed essentially how often these numbers showed up. And like I said earlier, if you look at the right on the graph, you can actually see that very high numbers showed up much less likely than lower numbers. So again, this is a trend that if people actually want to increase their chances, they're much better likely to, say, focus on lower numbers so that they can achieve those results. Finally, the third data visualization was achieved via a violin graph visualization, which simply compares the amount of winners to the ranking. So as you can see, the highest ranking state, which is actually Indiana, has a very high number of winners at 39. And this actually is a very acceleratory graph at the very beginning. It later steadies. So again, this does actually prove the point of this graph, which is that the state a player is in does matter, because obviously the highest state is going to have more winners than the second highest, but you can see that there is a drastic increase at the top 3 states as compared to the other ones in terms of lottery winners. So the geography at which a player does enter the lottery does make a huge difference. So the conclusion. So with this project, I actually learned a great deal not just about the lottery data, but specifically how I was able to get them. I actually learned more about this project to use pandas than I did the homework assignment, because it taught me how to group by certain elements, not just to say look for patterns first, but to actually just try the different data types with pandas to see the correlations and then work backwards from there, which was actually very helpful. I also learned how to implement regex in addition to Beautiful Soup. I actually wasn't really aware that you could use regex with Beautiful Soup data, but I actually found this a lot more helpful. And instead of just trying to find tags like the typical Beautiful Soup method would dictate, I actually was able to use regex more successfully in order to get those ideas. So at the end of the day, there is definitely many different trends to be discovered in the future about lottery ticket trends. And some of these that I confirmed with my research and my data manipulation in today's project is that there are 2 major proven trends. One being the amount of numbers that are chosen, that is the quote unquote lucky lottery ticket, so the numbers that are chosen, and in addition, the geography from which the person is buying the ticket. So, with that, thank you for listening and have a good day.